If you've explored Bitcoin at all, you've probably found its transactions confusing. What's a UTXO, what's a locking script, and why does all this stuff make my head feel like it's going to explode? Well, you're going to need to figure out the basics if you want to use Bitcoin safely, and luckily, I can help. Hello, my name is Trent Fowler, and I'm a machine learning engineer, public speaker, and cryptocurrency analyst. This channel is the home of the Futurati podcast, where we dive into how emerging technologies will impact the world and your bank account. So if that sounds good to you, hit that subscribe button to stay up to date. This video is about how transactions work. If you have more generic questions about the blockchain as a whole, check out the first video in this series, What is the Blockchain? I want to start with an analogy. Imagine having a magical check from the Bank of Gringotts in Harry Potter that somehow knows whether or not a signature is authentic. I could write $1 million check to my friend Nick, then leave it on the side of the road, and know that no one can use that money unless they actually are Nick and he actually signed the check. Even if someone has been practicing a signature for years, the check will magically know that it's a forgery. So I would have a way of sending money to people, knowing that it will only be usable by them, with no possibility of it being intercepted. Let's go one step further and say that no one can stop the transfer. This isn't a check I send in the mail. Once I've written it, there's no way of stopping the other person from receiving it. Now, without knowing anything else, doesn't that seem like the kind of technology that could change the world? There would be numerous use cases, say for funding groups which maybe aren't that popular with their government, or sending money overseas without a bunch of intermediaries to worry about. As we move on to discussing blockchain transactions, I want you to hold this image in your head. I think it'll help. On the blockchain, a transaction consists of sending an amount of value from one Bitcoin address to another Bitcoin address. Addresses are just these strings of letters and numbers which are more or less the same thing as a routing number or a bank account number. One way in which regular transactions and Bitcoin transactions are different is that regular transactions are usually two-sided. I give you something and you give me something. With Bitcoin, the only thing that's tracked on the blockchain is the transfer of value. So if I send 5 Bitcoin to my friend Nick's Bitcoin address, the reason I sent it to him is never recorded anywhere. Only the transfer of Bitcoin is recorded. That's what we mean by a transaction on the Bitcoin blockchain. But one way in which regular transactions and Bitcoin transactions are the same is that they each have two components. They have inputs and outputs. If your coffee costs $4 and you pay with $5, the input is $5 and the output is $4 to the merchant and $1 to you as change. That might not be how you normally think about a transaction, but it is an accurate description and it works pretty much the same way with Bitcoin. What's more, the inputs and outputs must have certain properties. The inputs have to be at least as big as the outputs, for example, so there's no way for you to create more Bitcoin by just somehow messing around with the accounting during a transaction. If the outputs are bigger than the inputs, the extra amount has to go somewhere. Either you can send it to another address, or if you don't do that, it goes to the miners as an added tip. And this actually dovetails into a discussion of UTXOs, which are not really that complicated, but honestly confused me a little when I first encountered them. On the Bitcoin blockchain, transaction outputs are called UTXOs, which stands for Unspent Transaction Output. When I sent Nick 5 Bitcoin, that Bitcoin now belongs to him, and it is a UTXO because it is the output of a transaction, the transaction in which I gave it to him, which he has not spent yet. So we call it an unspent transaction output. Bitcoin works on the UTXO model, which is distinct from how Ethereum handles transactions. In Ethereum, you have an account-based model, and your Ether are essentially placed in the equivalent of a checking or savings account. They all go into one big account, and you can use as much or as little as you want in a transaction. This is intuitive because it's basically how you interact with your bank. With Bitcoin, that's not the case. It works on a UTXO model, and UTXOs are indivisible. You have to spend Bitcoin in one chunk. Whether it's 1 Bitcoin, 1.1 Bitcoin, or 21.983 Bitcoin, it all has to be spent at once. UTXOs are indivisible. You can't spend part of the UTXO any more than you can spend part of $1. You can't cut $1 in half and get 50 cents. It's either $1 or it's just shreds of paper. Now, normally, when we have change from a transaction, it comes in these little units. For example, $1.83 would be $1, 3/4, a nickel, 3 pennies. The $1.83 can be broken up if you only want to spend 75 cents somewhere. With Bitcoin, it would be as if you got a piece of paper that just said $1.83 on it. You got the total change all in one chunk, and it has to be spent all in one chunk. You can't cut the $1.83 bill in half any more than you can cut the dollar bill in half. That means transactions have to be constructed from whatever Bitcoin UTXOs you happen to have lying around. So if you need 20 Bitcoin and you happen to have 20 Bitcoin, great. If you have 18 Bitcoin and 3 Bitcoin, you put those together to get 21 Bitcoin, and you spend the 20 Bitcoin and send the 1 Bitcoin back to yourself as change. Today, most of this is handled by wallet software, but it's nevertheless important to understand how it works under the hood. With all of that background in place, we can now look at this high-level definition from Andreas Antonopoulos and understand it pretty well. A transaction consumes previously recorded, unspent transaction outputs while creating new transaction outputs. And essentially, this is just how the Bitcoin blockchain works. It's these UTXOs ping-ponging around the network from one address to another. Now, it's important to note that outputs have two parts. There's the actual Bitcoin that's sent, and there's a little cryptographic puzzle that specifies what's required to spend it. When I'm looking at my Bitcoin wallet, I don't know anything about this puzzle. If I send Bitcoin to Nick, all I see is I sent Bitcoin to Nick. That's it. But how is it that when he goes to spend it, the network can trust that he actually owns it? How do we know he didn't just steal this? With money in your bank account, there's a very complex, labyrinthine system for keeping track of transactions and settling books, and all of that goes through trusted third parties. With Bitcoin, which has no trusted third parties, how do you verify ownership? Well, the details can get a little involved, and I don't understand all of them myself, but I'm going to give you what I do understand, and I hope that it will help you form a more complete picture of this process. When I sent Bitcoin to Nick, it created the UTXO, one part of which is called the locking script. And the locking script tells Nick what's required to spend the Bitcoin. In almost all cases, the locking script just ties the UTXO to a certain address. And addresses are not generated completely randomly. They come indirectly from a private key. We're not going to spend a lot of time on this, but briefly, a private key is used to generate a public key, which is then processed in a few ways to produce the address that you actually use to store and send Bitcoin. So if you have the private key that was used to generate the public key, that was used to generate the address, and the locking script ties the UTXO to the address, then the UTXO is indirectly tied to your private key. It would kind of be like locking money in a safe, but instead of just using any passcode, we use a passcode that was generated cryptographically from some piece of private information, like your social security number. If this talk of public and private keys is confusing, don't worry. You'll basically never need to concern yourself with the details. When you interact with a wallet, you'll probably only ever see the address and not any of the other steps involved. I only include this information so you can see how a locking script doesn't just tie a UTXO to a public address. It actually ties it to a deeper and more secure piece of information. That's it. What happens when we want to spend a UTXO? When we create a UTXO, we create a locking script that specifies what's required to spend it. And when we get ready to spend it, we have to produce an unlocking script which satisfies the requirements of the locking script. So the locking script tells you what you need to do to spend Bitcoin, and the unlocking script actually does that thing. This generally involves signing the transaction with your private key. With that done, the UTXO is unlocked, and we can transfer it to someone else. That's it for the Bitcoin transaction video. I hope you found it enlightening. Don't forget to like it and subscribe to our YouTube channel, or check out some episodes of the Futurati podcast where we talk about everything from crypto to AI to quantum computing to space exploration. And you can also follow me on Twitter at Trent_Stempunk, STEMPUNK. Thank you.